Hi students, in this video we're going to cover our second lesson for differentiation, and it is derivative rules. So before we get started, the whole lesson is going to be just around analytical or mechanical methods for deriving a function. But before we get started with any of that, two things are just going to be true. If I have a constant multiplied by a function, then the derivative of that function is the constant multiplied by the derivative of the function. You'll see what that means in practice. Um, and secondly, if we just have a bunch of terms that are either added or subtracted, I should put plus or minus, excuse me. So we'll put plus or minus. So if you just have a bunch of terms that are added or subtracted, you can just add and subtract their derivatives. There's no reason to calculate each part of the thing separately and then just add them together. So our first rule, and it's the most important rule in differential calculus, is the power rule. You have this constant multiplied by some function to a polynomial. So, or think polynomial type functions. So the derivative is going to equal, you take this exponent, you multiply to the front. So you're going to have n times k times x, and then you just subtract 1 from the exponent. Uh, a lot easier than maybe it looks. You just multiply the number to the front, subtract 1 from the exponent. So for a, we're going to calculate the derivative for the function. So f prime of x is going to be, now according to our rule, we're going to have 3 times x to the 3 minus 1 minus 2 times 5 times x to the 2 minus 1 plus 1 times 5 times x to the 1 minus 1. And then because this is a constant, it has no rate of change. A constant value has no rate of change. So that's just going to be plus 0. I'm sorry, get my I think so plus 0. Now obviously the we're going to take we took too many steps here. We all know 3 times 3 is 9. 3 minus 1 is 2. Negative 2 times 5 is negative 10. 2 minus 1 is 1. 1 times 5 is 5. So just plus 5x to the 0. So two things that we can take from this is the derivative of a constant. We're just going to actually write the word constant. The derivative of a constant is 0. And remember, the derivative is the slope function. So if you have a linear function, the derivative of that linear function is just going to be the slope. So when we had this linear function 5x, the slope of that line is 5. So its derivative should always be 5. That's what we got down here. Anytime that we're deriving a function that has a power of x, the power cannot be in the denominator. So for part B, we have to do a rewrite step before we can continue with before we can derive the function. It's important to know that we should not consider the rewrite step finding the derivative. So this is where labeling our functions is going to be helpful. So if we rewrite our function, we're still going to have f of x. That's going to be 4 times x to the negative second power plus 5 times x to the negative third power minus 6 times x to the negative fourth power. So this is still f of x, not the derivative. So when we do calculate our derivative, we're going to multiply negative 2 times 4, we get negative 8. Negative 2 minus 1 is negative 3, not negative 1. So then negative 3 times 5 is going to give us negative 15. And then we subtract 1 from the exponent, so we get negative 4. And then we're going to get plus 24 times x to the negative fifth power. Now, if you wanted to rewrite this without negative exponents, we would get negative 8 divided by x cubed minus 15 divided by x to the fourth, and then plus 24 divided by x to the fifth. From here, if we wanted to do things like find the equation of a tangent line or find the equations of a normal line, line perpendicular to the tangent line, we just substitute in the values and write the equation of the line as necessary. So we won't do that in this video. We're just concerned with actually the mechanics of how we derive a function. So instead of having just integer exponents, we can also come across cases where we have rational exponents. So in those cases, you're also going to have to rewrite your function. Remember, in general, the m root of x to the n power is x to the n divided by m power. So we're going to rewrite our function g of x to be, so it's going to be x to the 1/2 power plus 2x to the 1/3 power minus x to the 4/5 power. And so again, we've not found a derivative. We've just rewritten the function. So when we calculate this derivative, we're going to get g prime, or the first derivative for g is 1/2 times x to the 1/2 minus 1. It's going to be negative 1/2. And then we're going to get plus 2 times 1/3. That's going to be 2/3 x to the 1 minus 3. So negative 2/3. For my people who struggle with fractions, the denominator is never going to change. All you really have to do is subtract the top number from the bottom numbers. So like 1 minus 3, that's going to be negative 2. And then minus 4/5. And then 4 minus 5, that's going to be negative 1. And you never change the bottom number. I'm sorry, I forgot my x. So negative 4/5 x to the negative 1/5. So if you wanted to rewrite this so that it looks algebraically more presentable, we would have 1 over 2 square root x plus 2 divided by 3 times the cube root of x squared minus 4 divided by 5 times the 5th root of x. Now again, this for me this is not necessary. You can just leave the rational exponents. But textbooks and stuff may have different expressions. So part 2 is just 3 common derivatives that we need to know. For tangent, we can derive this even further once we learn the quotient rule. But right now, we're just going to write these 3 derivatives. The derivative of sine x is going to equal cosine x. And the derivative for cosine x is going to be negative sine x. Negative sine x. And the derivative for tangent x is going to be secant squared x. And we'll put a star by this one. And we're going to put quotient rule. And we'll see why this is when we get to the quotient rule. All right, so that's it for those 3. We just need to know those. So if you see them, those are the derivatives. Let's write a quick example. So say we have h of x is 2 sine x minus 3 cosine x plus 4 tangent x. For trig functions, there's not a lot of work until you get into products and quotients. So the derivative is just going to be 2 times the derivative of sine x. So it's going to be 2 cosine x. And the derivative of cosine is negative sine. So this is going to be plus 3 sine x. And then the derivative of tangent is secant squared. So we're going to have 4 secant squared x. And so this is what I was saying is that when you have a constant multiplied by a function, the derivative of the function is just the constant multiplied by the derivative of the function. You don't have to do anything with the constant. It just comes along with the derivative. So the last thing that we're going to do is talk about derivatives of quotients and quotients and products. Most of the time, you should try to see if you can multiply the things out. Using the product rule and quotient rule are more cumbersome for some calculations. So here, it's going to be easier to multiply these things out, and we're going to get, remember, we're not doing the derivative. We're going to get x to the sixth. I didn't even write a six, but I said it. So x to the sixth minus x cubed plus 2x squared plus x to the fourth minus x plus 2. Now, if you want to like collect terms and all that stuff and rearrange them, that's fine. I'm not going to. And so now we can calculate the derivative. That's going to give us 6x to the fifth minus 3x squared plus 4x plus 4x cubed minus 1. And again, the derivative of a constant by itself is 0. So if we wrote this in descending order, we're going to get 6x to the fifth plus 4x cubed minus 3x squared plus 4x minus 1. And just so we're clear, you cannot do the derivative of this function multiplied by the derivative of that function. That is incorrect. It is incorrect. For part B, you can pause the video, see if you can do part B without me, and then come back. So for part B, I would rewrite these as rational exponents. That's x to the 1/2. This is x to the 1/3. Then we're going to multiply those out. So x to the 1/2 times x squared, that's x to the 5/2. So x to the 5/2 minus x to the 1/2. Then x to the 1/3 times x squared is going to be x to the 7/3 minus x to the 1/3. And so that's what our rewritten h of x is. So our derivative is going to be 5/2 x to the, remember, just numerator minus denominator. So it's going to be 3/2, then minus 1/2 x to the negative 1/2 plus 7/3 x to the 4/3 and minus 1/3 x to the negative 2/3. And that's it. We're not going to worry about negative exponents moving to the denominator. We just want to get a derivative. All right, pause the video, see if you can do part C. Remember, properties of trig functions still apply. So if we rewrite our f of x, cosine times tangent is just going to be sine x because tangent is sine divided by cosine. So then we're going to have minus, let's see, cosine times secant, they're reciprocals. So this is just going to be minus 5x, then plus cosine x. So then when we find this derivative, that's going to be cosine x minus 5 minus sine x. That's it. And for part D, anytime you have a sum or difference in a numerator and then you have a single term in your denominator, you can rewrite the function so that every term is divided by the denominator. So what we can have is y equals x to the fourth divided by x squared minus 3x cubed divided by x squared plus 1 divided by x squared. And of course, that simplifies to be x squared minus 3x plus x to the negative 2. And so the derivative, or dy over dx, is going to be 2x minus 3 minus 2x to the negative 3. Because then we multiply the exponent to the front, subtract 1 from the exponent. In the case of any constant, its derivative is 0. All right, so that is going to conclude our video over the basic rules for derivatives. We covered the power rule and we covered the derivatives of sine, cosine, and tangent. And also remember, the derivative of a constant is zero. The derivative of a constant function is zero. Put an L here. Don't need that. All right. So thanks for watching. Remember, always keep practicing. I'll see y'all in class.